Good morning, students. Today we are going to start with second unit, second portion of AOD, application of derivatives, increasing and decreasing functions. Increasing function. A function fx defined on the interval AB is said to be increasing if for two values x1 and x1 is less than x2, then fx1 is less than equal to fx2. This is increasing function. In case of strictly increasing function, if x1 and x2 are such that x1 is less than x2, then fx1 is also less than fx2. Fx is function of x. Decreasing function. For decreasing function, if x1 is less than x2, then fx1 is more than fx2. In case of strictly decreasing function, x1 is less than x2 implies fx1 is strictly more than fx2. Now the first example I am sharing with you is show that fx is equal to 2x plus 3 for x belonging to real numbers is strictly increasing function. Let us consider two values x1 and x2 such that x1 is less than x2. Then 2x1 is less than 2x2. Let us add 3 on both sides. We can say fx1 is less than fx2. So we prove fx is equal to 2x plus 3 is strictly increasing function. Let us take one more example. Fx is equal to 1 upon x. X belongs to natural numbers is strictly decreasing. Consider two values x1 and x2 such that x1 is less than x2, then x1 upon x1 is greater than 1 upon x2. So x1 is less than x2 implies fx1 is greater than fx2. Fx is strictly decreasing function. If we consider it using two values 2 and 3, we know that 2 is less than 3, but 1 upon 2 is more than 1 upon 3. The function is strictly decreasing. Now we can also find out the function as increasing and decreasing by giving derivative test. If y is equal to fx is a function given such that x belongs to a comma b, then fx is increasing in the interval, open interval a comma b if f dash x is positive, that is greater than 0. Fx is decreasing in the open interval a comma b if f dash x is less than 0. Let us consider few examples. First question is fx is 3x square plus 2x plus 1 in the interval 2, 7. F dash x is equal to 6x plus 2. The value of f dash x will always remain positive for all values between 2 and 7. Let us consider f dash x at x is equal to 3. It is 18 plus 2, 20 positive. F dash x is equal to 4. 24 plus 2, 26. It is also positive. F dash x is equal to 5. 6 into 5, 30 plus 2, 32. So we get all the positive values. Fx is increasing function. Consider fx is equal to e to the power x, where x is greater than 0. F dash x is equal to minus 1 upon x square e to the power 1 upon x. F dash x for x is equal to 1 is minus e less than 0. F dash x for x is equal to 2 is minus 1 upon 4 e to the power half less than 0. F dash x is equal to 3 is minus 1 upon 9 e to the power 1 upon 3 again less than 0. So the function is a decreasing function. Consider another function fx is equal to sin x in the intervals 0 to pi by 2 and pi by 2 to pi. We differentiate fx is equal to sin x, we get f dash x is equal to cos x. Now in the first quadrant cos x is positive, so we can say f dash x is greater than 0 in open interval 0 to pi by 2, that is first quadrant. So fx is increasing in the interval 0 to pi by 2. F dash x is equal to cos x is less than 0 if x belongs to pi by 2 to pi, that is the second quadrant. In second quadrant the value of cos x is negative. So f dash x is less than 0 and fx is decreasing function, strictly decreasing function in the interval pi by 2 to pi. Consider the question fx is equal to x cube minus 6x square plus 12x minus 18 is increasing function on capital R. Now differentiate, we get 3x square minus 12x plus 12. Take 3 common, 3x square minus 4x plus 4. Using the formula a square plus b square minus 2ab, we get f dash x is 3x minus 2 whole square. Now square will always remain positive whether the value of x belonging to R is positive or negative. So f dash x is always positive for all R, that is real numbers. So fx is a real and increasing function on R. Find the intervals in which the function f given by fx is equal to x square minus 4x plus 6 is increasing or decreasing. Let us consider fx is equal to x square minus 4x plus 6. F dash x is equal to 2x minus 4. Now f dash x is equal to 0 if x is equal to 2. So between minus infinity to plus infinity we get two intervals, that is minus infinity to 2 and 2 to infinity, open intervals. Let us consider the first interval minus infinity to 2. Now we can see that in between minus infinity to 2, if we take any number 1 or 0, the value of f dash x is coming negative. If it is coming negative, then fx is a decreasing function in the interval minus infinity to 2. Whereas f dash x is coming positive if we take any two values 3 and 4 in the interval 2 to infinity. So f is increasing in the interval 2 to infinity and decreasing in the interval minus infinity to 2. Find the intervals in which fx is equal to 4x cubed minus 6x square minus 72x plus 30 is increasing or decreasing. Fx is equal to 4x cubed minus 6x square minus 72x plus 30. F dash x is equal to 12x square minus 12x minus 72. Taking 12 common and factorizing, we get f dash x is 12x minus 3x plus 2. Now f dash x is 0 for x is equal to 3 and minus 2. We can see on the number line there are three distinct intervals, minus infinity to minus 2, from minus 2 to 3, and from 3 to infinity. Let us consider the first interval minus infinity to minus 2. If we take any number in this interval, the value of f dash x comes positive. If we take a number in interval minus 2 to 3, 0, so we get minus 72 less than 0, that is negative. And in the third interval 3 to infinity, f dash x, we are taking x is equal to 7, we get 12, 7 minus 3 and 7 plus 2, again it is coming positive. So what do we observe over here? We observe that fx is increasing in the interval minus infinity to 2, fx is decreasing in the interval minus 2 to 3, and fx is increasing in the interval 3 to infinity. That is all about increasing and decreasing functions. Students, kindly do exercise 6.2 in your fair copy. Thank you.